Welcome to Forensics Investigations with Chromatography Lab. This lab consists of two parts. Part 1's objective is to identify the unknown accelerant used on the wood stick through GCMS, shortened for gas chromatography mass spectrometry. Part 2's objective is to analyze ink samples through paper chromatography. For lab safety, gloves and aprons are optional, while goggles and closed-toed shoes are mandatory. Additionally, since this lab includes an open flame section, tie up long hair. In the event of a fire, evacuate the class, pull the alarm, and call the fire department and UTA police department. If the fire is small, notify your TA and try to contain it. If your clothing catches on fire, use the safety shower or stop, drop, and roll. Part 1's materials should include a small beaker, a wooden stick, a separate 250 ml beaker of water, a pencil, tongs, a matchbox, scissors, and a GCMS sample vial. There are two parts in the GCMS procedure. In the GC or gas chromatography section, the components of the accelerant are separated based on its intermolecular forces, which makes some components take longer to leave the stationary phase and go into the mobile phase, while others may not even have a stationary phase. This causes differences in retention times that help determine the identity of each component. In the MS or mass spectrometer section, the component is fragmented into ions, which can be analyzed and detected. So basically, GC separates and MS identifies. For Speedier Lab, prepare the 250 ml DI water and GCMS vial. Wait for your TA to assign you an unknown accelerant. Record the unknown and pour some into a small container large enough for the wooden stick to sit in. Allow the wooden stick to soak for 10 minutes. If the stick is soaked for less than 10 minutes, there may not be enough accelerant soaked in, so the flame would not last as long. The wooden stick actually doesn't soak evenly, so try to make your pencil mark account for that. One partner should hold the non-soaked portion of the stick with tongs while the other generates a fire and lights the stick. Allow the stick to burn for 3 to 5 seconds. Try not to burn past the line and extinguish the flame by dropping the stick into the DI water. Once done, cut 1 to 2 centimeters of the stick that includes charred wood and any remaining accelerant-soaked portion. Place the sample into the vial and give to the TA to warm in the oven for 10 minutes in order to vaporize the accelerant, since GCMS can only analyze accelerants in the gas phase. Afterwards, carefully remove the vial and bring it to the Shimatsu Education Lab, located in room 113, to analyze with GCMS. Record your sample number and collect your analysis report for the post-lab. The website should send you an email containing your login username and password. Your TA should send you an email regarding the details of how to obtain your data. Once you get your chromatogram and mass spectra, they should look something like this. The GCMS automatically picks up the 3 highest peaks on the chromatogram. Be sure to check the peak areas to see if it is significant or not. Afterwards, compare the retention time of the highest peaks on the chromatogram to the table in your lab notebook stating where the peak should be for each accelerant. This specific chromatogram is only an example and will not be one of the accelerants you will encounter in your lab. As for mass spectra, the UTA system data automatically gives 3 possible matches for each peak. It's up to you to do some research into what your accelerant consists of to find the correct match. Lab materials for Part 2 should include 4 different brands of black pens, a piece of chromatography paper, a pencil, a stapler, 250 ml beaker with about 0.5 centimeters of DI water, a watch glass, a paper towel, and a ruler. Obtain the 4 different brand pens from your TA and mark down which pen corresponds to which number. After obtaining the chromatography paper, format the paper with pencil as shown. Place small dots on the X pencil marks with the different pens. Do it quickly and gently to avoid breaking the paper or smearing. Repeat and allow the marks to dry. Give your TA the chromatography paper for them to place an unknown brand of pen on the UX origin. Staple the ends of the paper and leave gaps with the color spots facing outside. In the beaker containing 0.5 centimeters of water, Place the paper inside with the pencil line above the water line and not touching the beaker. Cover with a watch glass. When the eluent front is about 2 centimeters from the top of the chromatography paper, remove and let dry, waiting a few minutes until the eluent front stops moving. Once the eluent front has stopped moving, mark each eluent front with pencil. Measure the distance of the spots and the eluent front from the origin. On the actual paper, the spots are not finely separated. You should measure the distance from the middle of the color spot. However, just be consistent when doing your measurements for accurate calculations. All excess accelerant and paper chromatography solvent are disposed of in non-halogenated waste. This wraps up the Forensic Investigations with Chromatography lab. Good luck and have fun!